So, well, a lot of them, many things we do with trigonometry is we try to find solutions. And one sneaky way of finding solutions is to take two polar equations, r equal to 1 minus 2 sine theta, and r equal to 2, and we'll set them equal and find out where the theta is that makes them intersect. So the first one, 1 minus 2 sine theta, equal to 2, you should be able to solve that. How many of you were able to do it? Sure. So if you subtract 1, you're going to get negative 2 sine theta is equal to 2 minus 1 is 1, divided by negative 2 sine theta is negative 1/2. Okay. So on the unit circle, y equal negative 1/2. What are the two places where those are going to be true? One over here is 7 pi over 6. Can you tell what this one's going to be? 11 pi over 6. Fantastic. So how would that look? Well, we would have for my coordinate r theta. Theta is going to be 7 pi over 6, and theta is going to be 11 pi over 6. What's the r going to be for the point? Well, you just plug it into this equation. 1 minus 2 sine of 5 pi over 6, or an easier one would be just to say, what's it going to be? 2. R is always 2. So those are my two coordinates. Now let's graph it and see if you'd actually see something like that. So I'm pulling up a calculator. I'm going to put in the two equations, 1 minus, and I think it was 2 sine, 1 minus 2 sine, it was just theta, right? Sine theta. And then the other one is just 2. Okay. And then when I check out my, I think everything's fine. We're going to go 0 to 2 pi. Ooh, this is going great now. And we're going to go from negative, I think we'll be all right, negative 3 to 3, and then this one down here is going to be negative 3 to 3. 2, 3. All right, let's see how it looks in the graph. There's that one. Perfect. And there's that one. So the 2, you can see the r equal 2 is the red one, and the 1 minus 2 sine theta is what they call a limacon shape. Dips in here and makes that. Is this a function? No. But it is a function when we put it in terms of polar, which is crazy. So if you look at where these intersect, they're going to be at 5 pi, there's 7 pi over 6, and this one is 11 pi over 6. Isn't that interesting? So it worked out perfect. It's exactly where we thought they would be. Okay, you try this next one. So what you're trying to get at here is that when you go r squared equal to r squared, what will happen is that this is just going to be, quiet please, this will be 2 sine 2 theta, and what's r squared here going to be? Just 1. And so we're going to divide by 2, and you'll just get sine 2 theta is equal to 1/2. Have we ever done anything like this before? Yeah, bunch of times. So if we look at the unit circle, sine x equal to 1/2, about right there. This will be your pi over 6, and this will be your 5 pi over 6. So 2 theta is going to be pi over 6 plus 2 pi k. And then the other 2 theta is going to be 5 pi over 6 plus 2 pi k. Then if I divide everything by 2, the 2 answers that I'm going to get will be theta is pi over what? 12 plus pi k, and theta is 5 pi over 12 plus pi k. Now between 0 and 2 pi, how many answers will that be? Between 0 and 2 pi, there'll be 2 pairs of answers, so there'll be 4. So the answers we're going to get for theta, okay, will be pi over 12 and 5 pi over 12. But we're going to get 2 more. And the reason we're getting 2 more is because this pi k, pi is 12 pi over 12. What's pi over 12 plus 12 pi over 12? 12 pi over 12. 13 pi over 12. And then what's 5 plus 12 is 17 pi over 12. And then what's the radius, or what's the r for each of these? 1, yep. So that wasn't hard. Those are the 4 points. Now, are there really 4 points? Let's see. We're going to sketch this one on the calculator. And would you go to square root? I'm going to do square root of 1 minus 2. I can't remember what it is. 1 minus what? Nope, there's no 1 minus. It's just square root of 2 sine 2 theta. Okay, so clear. Just clear the whole thing. Square root of 2 sine 2 theta. And then the other one will be the opposite of the square root of 2 sine 2 theta. Calculators are fun. And then the other one is just r equal to 1. When I graph those, you're going to see a little pinwheel taking place twice, and then a circle. And this circle is kind of interesting because what do you think these 2 arc lengths are, here and here? What do you think those are? Yeah, there's your pi over 12, and here's your 5 pi over 12. But what do you think these 2 are? 13 pi over 12, which is a little more than 12 pi over 12, isn't it? And then this one's going to be 17 pi over 12. Notice how these are straight across through the origin because you're adding pi. And those are your 4 answers with the justification. Then go to the other part that we had was sketching from what we call a set builder notation. Set of all r theta. R is between 0 and 3. Theta is between 0 and 2 pi. So we have a circle of radius 3. Okay? And if theta is between 0 and 2 pi, you're just going to fill all of this in. What if it were between 0 and pi? What would it be? Top half. If it were between pi over 2 and 3 pi over 2, what would it be? Pi over 2 and 3 pi over 2 would be this half. So you can control that pretty nicely. This one's going to be an actual a graph, and r is going to be between 1 and 1 minus 2 cosine. So you'd have to graph this and then think pi over 2 to 3 pi over 2. I'll let you do that on your own. And then on the next page, we're going to make our own set notation. So we'll start with set of all r theta. such that, and all of these are going to be set of all r theta such that r is between something and something, theta is between something and something. Well, if this is my picture at 5 and it's all filled in, what's r going to be between what and 5? Down to what? We're filling this whole thing in from what to 5? 0, right? And then the theta is all of them as well, 0 to 2 pi. And there's your set builder notation for a circle filled in. You try 42. So when you look at set of all r theta, you're just going to start with there's going to be something about r and there's going to be something about theta. R is going to be the circle to the center, so 0 to 5. But for quadrant 3, that's this one here, out 5. This is the part that's filled in. What is this arc length here, and what is this arc length here? Well, what will theta go to? What will the low be? Pi, and the high will be 3 pi over 2. Good. There's set notation. That's not so hard, is it? And then I'll leave this 43 up to you. And then we have topics for the test. It's a pretty basic test. You're going to have points, and you're going to find the 3 equivalents. And these are some nice practice ones I've set up for you. You can go from polar to rectangular. So you can take the point in polar, go to rectangular, or the equation go from polar to rectangular. Rectangular to polar. So here's your x, y. You change it to r theta. X and y in the equation go to r theta. And all the formulas will be up there for you. Graphing, I'm going to ask you to plot points and find points from a formula, simple without a calculator. We did the intersection. You'll have one of those. And set builder, there may be one of those. That's what the test is. Do those for practice. I also have some more practice intersection that you might consider, another graph one. And then these are not required, but here's some more intersection practice and points. And look at that, even more intersection practice. Holy cow. So a test coming up.